Now we turn AI risk into protection. In NIST CSF terms, protect means enforcing who can access systems, how data is encrypted, how models are built securely, and how environments are isolated to limit blast radius. We've already built the compliance map: inventories, data flows, risks, and obligations across HIPAA, GDPR, and NIST. This section shifts from knowing what matters to protecting it with concrete safeguards for data, models, systems, and threats. Protect is where identified AI risks become enforceable safeguards. For AI, that protection extends beyond servers and applications. Access control, data security, encryption, secure delivery, and platform hardening must also cover training pipelines, model artifacts, embeddings, vector stores, prompts, logs, and inference endpoints. The goal is to reduce the chance and impact of compromise, while producing evidence for audits, DPIAs, HIPAA safeguards, and AI governance reviews. Identity and access management is one of the first protections every AI system needs. Least privilege limits each person to the access their work requires. Single sign-on centralizes login and oversight. Multi-factor authentication adds proof before sensitive actions. Together, these controls reduce misuse across data, tools, cloud services, APIs, and model endpoints. Privileged access is where small mistakes can become major incidents. Admins may reach models, datasets, pipelines, cloud consoles, and production endpoints, so access cannot be permanent or informal. Use PAM for administrator and break glass accounts. Separate who builds, approves, operates, and audits. For sensitive actions, grant access just in time and only for a limited window. Then log the action, monitor behavior, revoke access, and review it regularly. In AI platforms, many actions are performed by non-human identities. Pipelines, model endpoints, vector stores, and integrations all need credentials to communicate. The safest pattern is to keep secrets out of code and runtime images, retrieve them from an approved vault, and prefer managed identities or short-lived tokens. Then limit each service account to only what its workload needs, and rotate credentials whenever policy or suspicion requires it. Access control is not a one-time decision. It has to be recertified as teams, data, and systems change. Periodic reviews confirm who still needs access to sensitive datasets, model registries, deployment tools, and APIs. Reviewers compare permissions against role, business need, classification, and risk. Then they remove stale users, unused service accounts, orphaned keys, and excessive privileges. Just as important, they keep evidence: approvals, policy exports, exceptions, and completed review records. For AI systems, encryption has to follow the data, not just protect the main database. Sensitive inputs may become features, embeddings, prompts, model weights, evaluation results, logs, and backups. Each handoff matters too: clients to APIs, pipelines to model endpoints, and internal systems to vendors. The rule is simple: classify the asset first, then require encryption at rest and in transit, wherever PHI, personal data, proprietary data, or confidential model assets appear. Consider a healthcare chatbot that sends prompts to a model endpoint, records conversations for monitoring, and stores embeddings for retrieval. Every hop can leak data if it is plain text or broadly accessible. Require TLS for APIs, pipelines, and vendors. Encrypt vector stores and restrict who can query them, because embeddings can still expose source facts. Redact or protect prompt logs, user identifiers, PHI, completions, notebooks, temp files, and evaluation outputs. Add retention limits. Encryption only works if the keys are protected throughout their lifecycle. Generate and store keys in approved KMS or HSM platforms, especially for sensitive models and data. Limit who can administer keys, separate that role from data access, and monitor every use. Rotation should follow policy, sensitivity, and compromise signals. If a key is exposed, rotate immediately, revoke old access, destroy retired material, and keep logs as audit evidence. Secure SDLC for AI means security is not a final checklist. It starts with requirements for data handling, identity, logging, model access, and abuse prevention. Reviews then cover more than application code: APIs, pipelines, infrastructure, prompts, and serving components all matter. Before release, add model-specific gates for unsafe behavior, sensitive outputs, automation risk, and regulatory impact. Production approval should depend on documented acceptance criteria, not informal confidence. Supply chain security means treating every external component as untrusted until verified. Libraries, containers, notebooks, models, datasets, plugins, and APIs should be scanned for known vulnerabilities and policy violations. The pipeline also needs controls: signed code, protected branches, approvals, access restrictions, and artifact integrity checks. For regulated use, third-party models and data require provenance review. SBOMs and model inventories preserve traceability, and critical findings should block deployment, not become exceptions. Before an AI change reaches production, treat it like a controlled release, not a quick update. Start with a change request, then test for vulnerabilities, insecure APIs, prompt injection, data leakage, access failures, and unsafe outputs. Next, review model, privacy, and risk impacts. Approval should be tied to evidence: test reports, versioned artifacts, rollback plans, and audit tickets. After deployment, validate behavior again, because change management continues after release. Segmentation keeps one compromise from becoming a full AI platform breach. Treat development, training, data storage, model serving, administration, and vendor access as separate trust zones. Traffic should cross boundaries only through approved controls, such as firewalls, private links, gateways, VPNs, or zero-trust access. Sensitive assets, including vector databases, model registries, and backups, should stay away from public services. The goal is simple: permit necessary flow and block everything else. Protect is where AI risk management becomes real engineering. Strong IAM limits who and what can act. Encryption protects data and models. Secure SDLC makes safe delivery repeatable, and segmentation contains compromise. Next, we shift from preventing failures to detecting suspicious behavior through monitoring, SIM, anomalies, and abuse signals.